Hello everyone. So I'm Alex. You saw me on the panel before. Thank you, Jan, for the nice introduction. I've been here at this conference actually maybe 6 years ago, roughly, so a long time ago. And it's impressive how things have changed in those 6 years. It's the amount of and the rate of change that we've seen in our discipline, and I think Rick mentioned it in the morning, is just incredible. And for me, I'm sort of, I started off in the BI and data management community, but then I moved on to the data science community, and sort of right now I'm in between both worlds, also in my organization. So I'm sort of have to deal with two things at the same time as the head of data, both the sort of more traditional, how do we get data in one place and so on, how do we deal with data quality, but also how do we drive innovation from data. And it's a very interesting stretch that you're in when you're between those two worlds. And I think this is also what the presentation is about. How can we bring those two worlds closer together again? I think we had almost in parallel two different developments in those communities, in the data science community and in the BI community. But I don't think that they should be so far apart. I don't think we do so much different things in substance. I think it's just the way we do it, maybe with some technologies. And I think that the data science community has also a lot to learn from the BI and data warehousing community, where a lot of problems have been already solved in the past. But also, there's a certain ignorance on the BI and data warehousing side, where you hear a lot of people who said, we've done that this way for plenty of years, why should we change anything? And maybe it will go away, like all the big trends, we will survive it and then everything will be back to normal. And bad news for those who think that way, because that ain't happen. So my keynote is data science for grown-ups, because I believe that a lot of data science in traditional corporates have been set up as labs, and a bit more in an experimental mode. I think there was one comment this morning about that in some companies you had those research type of kind of nerds in your organization for a long time who've done some crazy models. And now they became sort of a bit more mainstream, so you don't hide them, you put them up in front of other people and say this is sort of the future. But that doesn't solve a lot of the problems that we have, because we had those research kind of type of guys before, and they didn't solve all the problems we had to become a data-driven organization. So there must be something more to it than just having very, very clever people building models. And there must be something that, that connects the two disciplines. And this talk is really about how can we bring data science to this next step? What are the key lessons that I learned from working with different big corporates across different industries in setting up data science organizations, what I learned from trying to integrate those organizations into the rest of the organization, and also my recent experiences when I basically had a very, very, very fast startup of a data analytics unit at Volkswagen Financial Services, which the data unit didn't exist in the beginning of the year, and we set it up during a few months, and it's up and running and well running by now. And the only reason why I could go so fast is because we have a lot of people in the team that already made the experience of setting up such a unit, and I want to share some best practices or some lessons learned at least with you. So in the panel, we actually discussed about what are the biggest IT challenges that we face, and is big data the biggest IT challenge in the last decade? And as I clearly mentioned, no, I don't think so. I think there are three things that are really, really giving us a hard time in the IT space and in the sort of more traditional data space. And that is, the first thing is the flexibility that you get from the tools today. The rate of change, as I mentioned, of tools has become incredibly fast, with the whole open source community developing new features basically every month, with new tools popping up constantly, replacing an existing sort of state-of-the-art tool within a few months, with cloud computing, which publishes new services almost on a monthly basis. You have an incredible amount of choice, and you can basically adapt with cloud computing, you can adapt your sort of infrastructure on a daily basis, if you like. That is very, very different in terms of the flexibility that we had a few years ago when we had the data center that we had the tools that we had, and if we wanted a new tool, a new ETL tool, that was a big thing. It took us 3 years usually to implement a new ETL tool and replace maybe IBM with Informatica or Informatica with IBM and change everything, because it was a massive change effort. These days you can plug and play new things into it, and you have new packages for AI and other algorithms published by Google, by a lot of other digital players that just publish what they do as open source packages that you can download as Python extensions, and your data scientists expect to work with those packages very, very, very fast after they've been published. So that puts you in a lot of challenge. So number one key trend is the flexibility of tooling and IT infrastructure. The second big trend over the past few years has been the increase of agility and another paradigm of working between IT and business. In a way, IT and business coming closer and closer together. Gartner, I think, a few years ago said business and IT are becoming one when it comes to digital. So, and I see that in my organization, we usually struggle with digital topics if we don't put IT and business under one roof into one virtual unit. That's a very key insight for us. And the reason for that is because approaches like Scrum, Kanban, DevOps, they really need a fast, constant sort of way of interaction, and you don't plan everything for years ahead, but you basically try to find a business target, and then you run towards that business target, and you change your direction very, very often, every 2 weeks, every 4 weeks. And when you're talking about DevOps, you know, it's really about being able to implement changes within whatever software you have built, within a few days, a few weeks, and not doing a big change request and so on. So that really changes how you interact between business and IT, and having documents being sent around slows everything down. So if you want really to work in a way that is agile, you have to let people directly talk to each other and directly work with each other and owning the result together. So that's point number 2. And then the third trend, which is fueled by the other 2 trends, which is automation. I think that is really a big changer to the BI community. The BI and data community has been usually focused on decision-making support, trying to help leaders to make better decisions, trying to help operational units to make daily decisions. Which kind of new items do I want to order by when? Which stores should be equipped with those items and which stores shouldn't? All these kind of small operational decisions, but also some more strategic decisions, can be pretty much automated if you are data-driven enough, if you have the right data in place, which is a massive challenge, and if you develop algorithms that imitate human behavior or even improve human behavior. And all these machine learning techniques, data science techniques that allow you those automation aren't very new. We all know that it has been researched for decades, but now we have the computing power to do it. We have the amount of data to do this in many circumstances. It's not applicable across the business. But that really changes our reason to be as a data community. We are here not only to prepare decisions, but also to let machines make those decisions. So that's the biggest, maybe the biggest of those 3 paradigm shifts that we have, and it's sort of resulting of the other 2. Now, there's one very interesting observation that we could, if you look back the recent 5-6 years, how come that digital players invested not significantly more money into the data and BI and machine learning space than compared to traditional companies? Because I think since the big data sort of hype started, traditional companies started to invest huge amounts of money into all these kind of things that you could coin as or frame under the umbrella of big data. But how come the traditional companies never made it to scale those things really out across the enterprise? How come that you have Amazon, Google, Uber, Netflix, who run every single core process, and it's completely data-driven, and a lot of those operational decisions are already made today, that this is not science fiction, by a machine. And us, the rest of us in the traditional space, has paper-based processes where basically humans take decisions every day on a granular level that shouldn't be done by a human anymore because it's not effective. And I think this is a key question for us, because if we ask that question honestly, then we will come to, I think, some insights that will help us to accelerate and try to catch up a bit with the digital players. And I think something went really, really wrong when we tried to copy digital players and set up all these labs, this digital innovation camps and boot camps and startup things and machine learning groups. I think what we've done is we tried to not hurt our traditional business. We set them up in a sort of separate environment, in a capsule. And what happens if you leave the capsule? There are problems. There's no oxygen, you will burn. There's lots of different things that happen to you when you get outside the capsule. And this is what happened in most corporates I know. Now, going a bit level deeper, what does it mean? Inside the lab, we created cool, really working algorithms that could solve problems, that could automate decisions. But once they were put outside the lab, they burned. Why did they burn? Because suddenly, maybe you implement it in AWS, and suddenly you have to do it on Oracle and SAP. Have fun with that. 3 years project, probably. So no opportunity to shine. Every project will be sort of killed slowly. You've done it in Python, but on-premise you're only allowed to do it in Java, just as an example. You are not allowed to, by the way, to use those 5 packages that are standard packages for data science, because they are open source. You don't know what the licenses are. Could be a risk. That's something I've seen in big corporates. You have legacy IT systems where people tell you, oh, you can't touch the system. Great idea, but you can't touch the system. If we touch it, something bad might happen. Nobody knows really how this system works anymore. We have digital labs that get millions of budgets to spend to scale those kind of ideas that they have and proven ideas, and they can't spend any money because they have a purchasing department that doesn't allow them to add the vendors that they need on their list, because it takes really a lot of time. Working with a startup in a corporate environment is nearly impossible. I know some really excellent startups in Tel Aviv, for example, AI startups, where I would love to work with them, but it would take me 2 years to start working with them. And having a new tool in your environment, being installed in a productive way takes you also, at least a year or more in a corporate. You have to do RFPs, they take long. So you're basically, even getting suppliers to help you can be quite tough. And it's basically the expectation of your board is that you can implement something extremely fast as a digital organization. That's the expectation. If I tell my board it takes 9 months, they will tell me, well, That's a long time. And then I tell them, have you looked at the other projects, how long they take? They take usually 3 years, not 9 months to get productive. But the problem is that the expectation is really high, and those approval and purchasing processes are really, really slowing you down a lot, because they are not set up for buying digital stuff. They are set up, at least in my company, to buy car parts, to buy engines and things like that, but not to buy software tools and buy agile services from agile companies. And of course, there's this whole risk security, compliance, regulation thingy, where it's absolutely clear that we need to be compliant. It's absolutely clear that we need to be secure. It's absolutely clear that we need to have data protection in place. That's a must. Whatever you do, you need to comply. That's not debatable. But what happens is that you create something on new tools that just don't fit the standards of the department that does compliance in your organization. So basically, there are rules set in stone that might need an update, but they never got that update for this sort of new digital age. They still, use the same criteria, the same rules internally that avoid you from putting something from a lab environment into a real environment. Just to give you one example, you have data. Sometimes you have data protection rules, which, at least in German companies, which don't allow you to do any analytics with your customer data. That's not fun if you're in analytics. What would be the right thing to do is to look at the law, look at the regulation, and see what am I allowed to do? What do I need to ask the customer to be allowed to do that? That would be a different approach, but that would require an update of those processes. And then we have some other issues. Deployment. Deployment, basically, if you want to do a deployment with CCID pipelines, which means, this is what you do in modern DevOps. You basically try to automate all your deployment, and you do infrastructure as code in the cloud. Well, if I talk like this to my ops department, they don't understand much of it, and they don't appreciate that discussion. Same with IT operations. DevOps is seen more as a risk than an advantage in most IT operations. So that's also another tricky bit, because try to hand over an algorithm, an AI algorithm or machine learning algorithm or simple data algorithm, and try to hand it over to a traditional IT operations. How should they support that? That's very tricky. You need data ops or DevOps. And you have data quality issues. You have strong cultural resistance. You have a lot of people who see it as a threat, what you do, and they don't support you once you're out of here. And it's an ignorance that goes both ways between those two worlds. And finally, and that's a problem of these guys, data scientists usually have no clue about the company. Some have been there for a lot of years, and they are really knowledgeable, but a lot of the data scientists don't really know how the company runs. And they could maybe solve a lot of these problems by talking to the right people and arranging it, but how do you know who to talk to about which thing, how do people think and so on? You don't know that if you haven't been in the organization for a long time. So those are all the reasons why once you develop a diamond here, it sort of burns once you put it out in the atmosphere. So to summarize, we have a free like a bird environment 1, and you have a cage bird environment. So in the free like a bird environment, in the innovation lab, you can do whatever you want. And there are almost no restriction, but once you put it out there, it's very, very heavily restricted. Now, what could we do about it? Any ideas?
Yeah. Bring the innovation into business and not make a lab.
That's a very clever idea, yeah. Very obvious in a way.
It should be there.
Yeah.
Inside business, not separate.
So the gentleman is saying that we should bring the innovation into the business and not having it as a separate sort of capsule. I think that's a good. Any other ideas? Can you speak up?
Move the data out of the IT systems.
Well, it's sort of part of the solution, yeah. So moving out the data out of the IT systems.
what you could do is take some of the people from outside and put them in the lab so they understand all the restrictions before they go into the lab. So they practice on their own.
Yeah.
Not all of it, but some of it.
Yeah. That's good. I think here we have.
Make it possible to do as a business deploy models without involvement of our team.
Yeah, that's a good, might be a good idea. Well, I personally think it's better when business and IT work together, but yeah.
But then business becomes IT.
Yes, but IT is still under the CIO, and if they are not with your team, they fight you. So it's better to be on one team. It's at least my experience.
If you really have business buy-in for this sort of approach, then they need to be putting pressure on supporting processes like contracting, procurement, and regulations.
Yeah.
Getting them to consider the big picture instead of just working as links in the chain.
Right. Yeah. Okay, we take 2 more, and then I show you my part of this.
Isn't the whole problem though that digital players aren't trying to apply machine learning, automation, this kind of thing to stuff that already exists? They're using it to not solve problems, but to develop opportunities and improve their businesses, whereas other non-digital players are trying to use the same tools to do different things. They're trying to solve problems that they have. They're not trying to achieve what the digital players are trying to achieve.
Yeah.
I mean, that seems to be the fundamental problem. So they need to stop trying to solve problems. They need to start using it to not necessarily improve their processes, but to bring them new opportunities.
Well, I guess digital players do both things, but I think the key thing is that we really focus on the key value parts of the sort of key parts of the value chain. But okay, last comment here, over here. You have to run, Sam. But all good comments, and I think there's no silver bullet, of course, as we know. But I will share a bit of my lessons learned and tactics.
I have more of a question. I haven't worked for digital players. Do they actually have IT department? Do they have procurement department? Is that how they're structured? You know, what is their organization structure?
You mean in the digital players?
In the digital players, the ones who can, you know, successfully implement it outside the lab.
Well, they do, but it operates very different. As I said, they are not there to buy metal parts.
Yeah,
so it's
okay.
really
Well,
different.
I
They are more like enablers, not controls so much.
Yeah, yeah. So I suppose it's just a different, you know, they must have a different operating model completely to do that.
Yeah.
And is it really possible for a traditional company? I work in a very traditional company. It's been around many hundreds of years. So can you go digital in a very traditional company without breaking those kind of, you know?
I think it's a good transition. So I will stop the discussion now, and I will try to show you a bit. I will try to show it in the next few slides, basically, what I think about it. But thank you for the question. It's a good question. And we will have, if we have time, how much time do we have? So I think the key thing is that we need to build a bridge between those two environments. And it means 2 things. One, we need to free that bird a bit. And the second part of it is we need to cage this bird a bit. So in a way, the left environment, the lab environment is too free, and the right environment is too restricted. And we need to, you know, to come towards each other and try to find a middle ground where both can live with it. That's sort of in a very, very, you know, summarized way, you know, I think what the tactic, what the strategy could be to and that, you know, that's where I've seen things working. And I will highlight a bit what it could mean. And I call this the sort of the factory concept, the data and AI factory concept, which is, you know, basically an opposite to a lab. And it's basically an organizational concept. Some organizational lessons learned. That also includes some broad architectural guidelines, not so deep as Rick's guidelines, which can also be applied when you go deeper into architecture. Rick van der Laas, on logical data warehouse, those are all things that can help. But this is more on a higher level, a sort of a construct, how you can think about a problem. And it contains 5 components, and I would like to highlight them. So the first component is the data and AI platform that needs to go across those 2 environments. So the lab environment and the environment out there needs to have a common basis across those 2 worlds. And the logical data warehouse, as suggested by Rick, and I now understand it even better after I've been to his tutorial, actually can be a big component of this in terms of architecture piece, where you try to have virtualization, try to have sort of physical data storages and a good metadata management mixed up, and then you can give different users, data scientists and machine learners, maybe more raw data, self-service BI people, sort of some data that is sort of in between, that is not so raw, but also is still integratable in different ways, and maybe the more reporting guys, very data that is pretty much structured in a certain way, and you have to eat it as it is, basically. And a logical data warehouse environment, a data and AI platform, in a broader sense speaking, allows you to cater to all these needs in one architecture environment and not in these separate worlds. And I think that is a key thing, that we start thinking about a common state of the art tool set with a sandbox box development and production environment, which allows me to have something tried out in sandbox, then develop with it, and then bring it live in the same tool stack. And it needs to be updated, because we can't do that in the current tool set in corporates. You need Python for that, for example, and that's the second point. As programming language, you need all the packages that come with it. You need all the things that a modern data scientist or machine learner, also self-service BI users want. And this needs to be set up on a common platform that ensures security, data protection, and compliance. Because this ensures that once you move it into production, not massively, you don't have to reinvent the wheel again once you push it out. And the data layer basically needs to be a common data layer. This is what I meant with the logical data warehouse. It would be good if basically all the data that you use after a while is coming from that data layer. Of course, you will have some point-to-point connections, but basically all the new projects should actually be through that data layer. So after a while, you have more and more data points coming through that data layer. And that would allow you to have the same data connection in sandbox, in development, and in production. And that's very, very powerful, and for whatever users you have. And that is pretty important, having those, having this data layer also as a data access layer, where you also control who's allowed to see which data for which purposes. And this gives us control back, and that allows us to do stuff in production that we haven't been allowed to do, because you have the sort of layer of governance that you didn't have before. So in a way, it's really those things that need to go across from sort of the innovation environment towards the traditional IT. One layer of the tools, one layer of the data, one layer of governance and security, one layer of access to data and all those access rights, and also one way of getting data out of the systems. Well, there are multiple ways, but basically they should all connect to this sort of common platform. And that will, of course, not be done overnight, and that shouldn't be built sort of bottom up, but more top down, use case by use case. You plug in more stuff as you go along. So that's the first very important component of the data and AI factory concept. The second concept is you need to update some of the processes around that. And I invented this funny please framework, which basically looks at the processes that you need to revisit and to change so you can really run smoothly in an agile way. The first one is purchasing. I mentioned it before. You need to be able to work with new tools, with new startups, and so on in a faster way. The second one is legal. You need to have clearer rules what you're allowed to do and what not. Running always to your legal department for every case doesn't make sense. And legal departments are not fit for that, to have millions of people asking what kind of use cases am I allowed to do. We need to standardize the legal frameworks. The third thing is evaluation. We need different KPIs to look at digital success than in our traditional business. It's not about bending metal anymore. It's not about the KPIs that we had in the past. So we need to put new KPIs in place, like digital touch points, the number of digital touch points, the loyalty rates of customers on digital platforms, and so on. Then the auditing rules. So A, for auditing, we need to update also how our own auditing rules inside the company, of course, within the legal framework and the regulatory frameworks, but still we need to look into how does cloud play into this, public cloud, how can we use it in a legal way, for example. Security is very different when you just do on-premise or if you do a hybrid environment between cloud and on-premise. A lot of security officers are afraid of the cloud. We need to be able to move ahead and find solutions to make everything secure, but in an environment that is fine for everyone. And the last thing is ethics. I think that being able to do all these crazy, cool, new things with algorithms puts also a lot of risk when it comes to ethics, and we have to be very conscious and put that into the processes, think about ethics. The third component are data platform engineers, or data engineers, data platform engineers. So I think we always talk a lot about data scientists, but I think the key resource of the 21st century is a data engineer, not a data scientist. And one of my jobs as the head of data is to make my data engineers so happy that they never leave. That's probably the most important task that I have. Everything else is neglectable compared to that. Because if one of them leaves, we probably can't do half of our projects. Those are the people who plug in cables between one system and the other, let data move around the company, find solutions to put enough security in a public cloud environment that it can connect to an on-premise environment, install all these cool new services on the cloud, make sure that you can also install these things on-premise and make those things talk to each other. Writing APIs, integrating data, running agile ETL processes with the new tools that we have today, creating continuous integration, continuous development pipelines, infrastructure as code, testing and deploying those products, data and AI products that are developed, and also adding new components to the platform. So they have a massive responsibility in this whole space, and this is really, well, if I was working in the data warehouse and BI space, I would look into getting those add-on skills that you need to become a data engineer, because I think this is the hot job probably of the century now. And I think you're very close. If you're a technical person in the data space and BI space, I think you're very close to this. You just need an upgrade, maybe with some skills, but it's not so far away. But there are, of course, some new things, but the cool thing is one can learn it from, Amazon has thousands of tutorials, for example, for AWS services. And even our data engineers learned that. In the beginning of the year, they didn't know anything about Amazon. They were just clever people who learned it. The fourth component is the ops part. So you need engineers to plug everything in and have a platform. But once you have an algorithm that can run on a platform productively, somebody needs to operate it. And it sounds very simple. Okay, you need maybe ITIL processes for this. And in a DevOps way, of course, maybe not so strict as ITIL, but you need to sort of to monitor what's going on. You need to have a ticket system for problems. You need to be able to resolve those problems, document them, handle change requests, do logging, do security monitoring, and all these kind of things. You need to do that also in a machine learning environment that is productive. The problem is that those tasks are not really perceived very sexy by the people who do data science, machine learning, and data engineering. So basically, if they have to do it all day, they will probably find another job. That's why it's a bit of a challenge, because you can't really give it to traditional IT ops. So there are different strategies. It's not so easy, but trying to maybe get somebody from the IT ops team on your team and to work sort of together and do some training is maybe a strategy. Having some people who are willing to maybe they are not so good in pure data engineering, they are not there yet, but they want to learn it. Those could be the right people to do data ops, because they have to learn everything from the data engineer in the handover. So those could be good people. So it could be sort of your apprentice system. People learn it in ops, and then they move and become data engineers afterwards. So of course you need ops when it comes after deployment. So it really goes up after deployment. And the problem is, the more products you deploy, the more algorithms you deploy them, bigger your ops challenge becomes. The good news is that if you run stuff on AWS, for example, you can do zero ops sometimes, which means you can have functions that don't run on a server, but basically they sleep, and once somebody opens up the API, they awake, and Amazon manages it for you. I think similar concepts are also in Azure and other cloud environments. So there are, usually you will end up in a hybrid environment after a while in such a data and AI platform of public cloud and on-premise stuff. And so some stuff you can run in the cloud, even productively after a while, and there you really benefit from some of the techniques to really reduce the amount of ops that you need to do. Now, one of the key things that I find is also that data scientists and IT operations don't speak necessarily the same language. So explaining ITIL to a data scientist is maybe more difficult than explaining data science to an IT operations guy. So basically, data scientists think that IT ops are a bunch of bureaucrats. And data scientists feel really misunderstood, because they feel very complicated. They feel everything is so complicated, so slow. But, if you worked day and night to create this great algorithm, and you want just to bring it live because it's so great, and you worked you didn't sleep for 10 nights, to build this, and then you go to this ops guy and he said, "Well, young man, what can I do for you today?" And he said, "Well, I just need to bring it out. Have you filled in the form number 1, 2, 3, 4, 5, 68, 85, and so on?" And sort of data scientists go mad, and they usually, if they are in this situation for too long, they probably look for a different job. That's what happens. And on the other hand, this guy is right. Data scientists need to grow up, because you need to monitor your security on the platform. Once an algorithm is running and it's determining what kind of materials to buy or what kind of prices to give to your customers, it needs to be secure, it needs to be maintained, it needs to have 24/7 support, it needs to be updated once you have new software releases, all these kind of things that we know from the IT world. And data scientists have no clue about those problems. They just don't know these problems. So rightly, IT ops tells them to grow up. And that's why I called it data science for grown-ups, because I think data scientists need to grow up. And I found a good solution. It's a third role. Well, we have the data scientist. Well, sort of a fourth role. We have the data scientist, we have the data engineer, we have data ops. And the fourth role is the data product manager, or data and AI product manager. And this guy is more the communicator type of guy. He understands algorithms, but he also understands, he's not so deep into the algorithms, so he can't talk anymore to anyone. Basically, this is a person who both understands IT and business and data science. And this guy or girl needs to be involved basically throughout the project, from ideation, really trying to find great ideas for algorithms inside the business, doing the change management, explaining to the different traditional business functions. By the way, traditional business functions are not so modern as you might think. So it's not only an IT problem, there's also a big change management problem on the business side. So you need this person to explain what you can do with algorithms, to find the sweet spots to do algorithms, and to inspire the business to do something. And then to manage the data product from, first idea validation to development to piloting it in an MVP mode, a minimum viable product mode, and then to operations, And throughout, and of course in between you have deployment, which is maybe the biggest hurdle. And throughout that sort of value chain, it's good to have one person that is ultimately responsible. I call them the mini CEOs. The guys who really own the use case and throughout the value chain. And the cool thing is that those people, they exist. And you don't need any unicorns anymore for data scientists. You can have really technical data scientists, and with this person in between, they understand the data scientists, and they also understand the traditional business and the traditional IT. And everyone is happy at the end. So this is an incredibly important role, not only in project management, not only in stakeholder management, and it's sort of a bit of a unicorn, but it doesn't have to be the sort of ultra techie person to do that. So those 5 things, those 5 elements really make a big difference. And I think there are a lot of other elements that are important. And I think in the beginning we had this discussion what you can do about this big challenge of scaling stuff outside of the lab environment. And you all had very interesting perspective, very important points to say. But I do think that those 5 key elements, the platform with the sort of logical data warehouse, as I learned, as a basis across those 2 worlds, with processes that are updated to fit this new world, using this please framework that I suggested, having more engineers, hiring and also training more data and AI and platform engineers that actually can code and set up stuff, not sort of architects that draw on PowerPoint, but architects that really do technical architecture and implement those architecture. Having data ops or DevOps, for data and AI products in place, which is really a new thing. It seems to be the same thing, but it's really a new thing, and everyone needs to learn. And then finally, having product managers as your key stakeholder managers and as the key project managers and product managers across the product development and deployment and operation. Those are really 5 critical elements of the organization concept and sort of the architectural guidelines that help you to create a factory that can scale from a lab environment across the different business parts. And at the end, it's the role of the data product manager to bring that innovation in the different parts of the business. And you need them really as advocates to bring them into the different types of business processes, different types of business functions, maybe other business units, to bring that innovation there and to have people, give people the experience what you can actually do with data when you have such a wonderful setup. And that will lead to a lot of astonishment in a positive way. That's what I can really tell you from my experience so far. So to summarize, I think that we are on a point where the 2 communities of data science and BI and data warehousing need to come back together and work on this maybe biggest challenge that we have to make our organizations more data-driven. Thanks.